So this is it, folks, the last session of the summit. I think it's going to be a really exciting one. Great panelists here to talk about AI for social good. Just a reminder, if you haven't heard it already, we really want your feedback on those surveys. It really helps us build agendas for you and topics of interest for you. It helps us with our speakers and our feedback, and as speakers, we all look at it and really take the feedback seriously. If you don't know where they are, emergency exits are on both sides. Washrooms are on my right, your left. And hopefully we'll see you all at the 5 o'clock closing ceremonies. And with that, I'll hand it over to Sanjay to start going with this panel.
Thank you so much. Good afternoon. Thanks really for coming here. This is really a very important topic, and we really need a lot of people to get engaged. This is really my honor to present one of the best panels I could ever get. We have Prem. He's the Vice President of Alexa. He works on natural language processing. We have Jim Carosa. He's the Assistant Director of SCIENCE from the National Science Foundation. We have Patricia Bremen. She's the Director of NLM, National Library of Medicine from the National Institute of Health. We have Thomas. He's the Vice President of Discovery Park from Purdue University. And we have Azar. He's the Director of Harari Institute from Boston. All of them are one of the topmost leaders in the countries in their respective field. It's really a pleasure to have them part of this panel. So before we go, a couple of things, given the sensitivity of the subject, given the interest in the subject. I hope I can move the slides here. Perfect. So if you have any questions, already I have received several questions from many people. So we will select it based on how they come. So if you have any questions, just send an email to aiquestions@amazon.com. After respective talks, I'll take the questions and I'll select some of them and I'll ask on behalf of you. Just a minor disclaimer, the opinions given the sensitivity of the subject are our own, nothing to do with views or opinion of Amazon or AWS in that particular case. In most of the time, sorry for the background. Most of the time, I'll discuss about machine learning or AI or sometimes deep learning. Sometimes I'll mix all between the three. AI is a field that started in 1950s. It's not a new field. It has been there for a long time. There were regenerative algorithms in 50s, but slowly in around 80s, machine learning came up. And if you remember all your spam filters, right? They all run on machine learning. All your recommendation system, for example, from Netflix and all, right? That runs on that. But slowly, around about 7 to 8 years ago, deep learning came into place. Simply because we started getting accelerated computing, right? And that means you can do much more faster processing. I'm sure you all know a single CPU will have 10 to 100 cores, whereas GPUs have thousands of them. So deep learning started coming up along those lines. And immediately, as you can see, a couple of the fields become very interesting, right? So for example, convolutional neural net. So convolutional neural net is a mechanism where you can distinguish objects in a given nodes or edges of the object. The second thing which became interesting was what we call natural language processing or automatic speech recognition. And Alexa is a classic example of that. And so does autonomous driving and so on and so forth. Typically, as I mentioned today, I'll mix these things together because sometimes it's really hard to disentangle between the three. But generally, machine learning, people look into three ways. Supervised learning, most of the stuff people do are what we call supervised learning. This is really task-driven, where you start with a given training data and give an output. But there are unsupervised learning, and that is completely data-driven. Do you know how complicated just to program "Hi Alexa," this particular word, so that Alexa can make it wake up? It's very complicated. And one of the ways to do that is called algorithmic learning. So I just record it and train the machine. It's much faster than that, than writing a full algorithm just to model that word. And then there is something called what we call decision making. You might have heard about reinforcement learning. These are training by data, but also you can start taking action. So one of the major applications for that you can think of is how can we tell robots to do surgery? And that is anti-reward based systems, right? So typically machine learning comes into all these three flavors, but there are always a combination of all of it, right? So machine learning, I mean, in general has a tremendous potential. Just look at the Nobel Prize of last two in physics. In 2017, this was Nobel Prize to get to detect the gravitational wave, and this was funded by National Science Foundation and a few other agencies. And the Nobel Prize of Physics, which went to Higgs bosons at the LHC. Do you know how people detected that? Let me give you the example of Nobel Prize for the Higgs boson. We classified into 6-channel how the particle will decay, and we used neural net. We used Monte Carlo simulation to get guidance. We did boosted decision tree to find rare particles inside it. So machine learning has tremendously moved the world, right? At the same time, there are tons of good things happening. For example, this is a recent collaboration we did with National Science Foundation as well as University of Nebraska, where you start to learn how to detect wildfires. This is another example of Hurricane Irma, which is again funded by NSF Big Data Award, in which you train the machines using past hurricanes and start predicting it. What's shown is here in the left side is machine learning using a predicted path, and the right side is the real path. And imagine you can predict a future hurricane. Even half an hour before the path, you can deploy Red Cross and other agencies to help it. This is another example, Thorn. Thorn uses AWS to help law enforcement identify child trafficking. There's a lot of beautiful things happening. It helps to identify sex trafficking and ads and so on and so forth on a daily basis on a large scale. It's really evolving capability. If I look back and think about what is evolving, computer vision is already in an advanced stage. Speech and audio processing is quite advanced. Prem will talk about natural language processing via Alexa. Many people in the world they use. The content generation is highly developed. Reinforcement learning started picking up. So it's already quite an advanced area. But still there are negativity along the areas, right? And this is actually opportunities. I mean, let me give you one single example. This is a fantastic study. It was in 1970, what I call art of human decision making, okay? In this particular study, what happened was a particular person was found, she was found with possession of illegal substance. And 48 judges, it's a hypothetical study, it's published here. 48 judges, and they found a couple of evidence that it was consumed, right? And they asked 48 judges to tell whether the person is guilty or not. She was a woman, and they found at her place. In this particular example, 28 judges said, no, she is not guilty with the respective decisions. 17 judges said, no, she is guilty. Now, in this particular example, they changed the mechanism. Instead of female, you say a given minority race. That entire decision started changing up, right? So biases are extremely vital, and this is a published study. And sometimes algorithmic learning this is an opportunity for algorithmic learning. So one of the advantages is that it is easier to get same decision given the same evidence. So it's a huge opportunity for algorithm. So you could, irrespective of the age and gender and all, if the evidences are same in algorithmic learning, you get it. It's a huge area of applicability: health sector, crisis management, public financial, legal. What we need is, we really need an AI-based infrastructure where the companies, the government organizations, the industries, as well as education sector should be part of it. Let me tell you an example. I came from a village in India. The roads were not so beautiful. some shops are air conditioning shop. I mean, they have everything. And some shops do not have roof, right? The people who have an air conditioning shop are not going to fix the roads, right? So it's a common, in order to create infrastructure, it's a shared responsibility. And that's why I'm really excited that we have panels from the foundations of the agencies from the country. And this is what infrastructure looked like in 1920s, where you can drive left, right, doesn't matter. Nobody is going to tell you what is correct. But at some stage, in order to make AI-based infrastructure, you have to start creating traffic lights. You have to start creating regulations, right? And and regulations means we have to really discuss and come into a place on what we call fairness. And even fairness has 21 definitions. There are protective attributes like race, age, gender. There are classification in parity. But the end point is the outcomes should be independent of what we call protective attributes. We also need to have transparency. How do you trust algorithms' decisions? It has to be explainable, right? DARPA recently started something called explainable AI. So these are really good questions. There is no single answer, and only way to move forward is to work together, both with industry, with government sector, as well as educational institute. So with that, let me give you Prem Natarajan. He's the vice president of Alexa, and he will talk about the areas where he's trying to work along those lines. Prem.
Thanks. Thanks, Sanjay, for that intro. Any of you wonder if that chair is uncomfortable? I can offer you confirmation. But on the other hand, we're putting social good on a high perch, right? So that's the plus side to it. So let me move on to the next thing. So we're talking about AI for social good. I think it's really an interactive conversation. So my goal here is to frame the discussion in terms of how I see this specific domain of application of AI move forward, and what each of us as stakeholders or different equities in this can help to move this forward. So when we say AI for social good, what, the two questions, what is AI? I think that's fine. It's a discussion that everybody's involved in. But when we say social good, I tend to see social good as a bit of a continuum. Many things have social good impacts. But anytime this topic is discussed in a forum like this or in other such venues, we think of things like education, faster, cheaper drug discovery, more effective policy making, predicting, responding to natural disasters. There are a combination of societal challenges where there might not be an inherent business model for commercial entities to be involved in providing a solution, or they might be things where even if there's commercial investment, where a community investment like in drug discovery, et cetera, might accelerate things so that the benefit is available broadly to society faster, right? When we look at commonly accepted attributes of AI for social good, like when we say what these communities that are working in AI for social good, what do we see? We see first that it's usually a collaboration of multiple disciplines, especially of social sciences and AI, but of life sciences and AI. So this is AI plus something. That's typically AI for social good. These teams are integrated. It also often is in the form of a public-private partnership. There are people who are in it for the discovery, for the advance, and there are people in it who are providing the AI services. It's also characterized by open access to technological resources. These are open development environments. Things are then available. I think one way of looking at it is everybody's contributing to a rising tide that lifts all boats. And then considerations of bias, fairness, and accountability of ML algorithms are usually part of the discussion in this. Whatever one might mean in terms of what are the factors of bias, what is fairness, et cetera. So what's the current state of this? I mean, it's clearly a trending topic. There's a lot of interest and discussion. It's in the media. But the current state is there's growing investment in what one might call AI for social good across sort of the primary equities in the academia, industry, government, society. There's lots of foundations that are involved. So there are several now. If you go into a Google search, you'll find several academia-based centers for, they're often called AI for Social Good or Center for AI in Society, things like that. Attacking a variety of problems from poaching, animal protection, to climate change and different things. So each one of these has a thematic focus of its own, but they're usually situated at the intersection of multiple disciplines within academia. Industry initiatives span in-house efforts. All the big companies have some kind of in-house effort that's focused on either fairness, accountability, or social good. At Amazon, one of the things I can point to is the collaboration we've launched with the partnership with NSF, where we launched this NSF Amazon Fairness Program to fund research in academia. There's also substantial government investments, and here I think, not that it's DARPA exclusively, but DARPA's investments exemplify the government's approach to this because it addresses all the attributes I was talking about. Lorelei was about humanitarian assistance and disaster relief. MEMEX was about child trafficking. It was the first large AI investment specifically in the problem of human trafficking, all forms of human trafficking, sex trafficking, child and labor. Even it was extended to arms trafficking in some senses. World Modelers, which is really about solving world hunger in a way, but applying AI to that problem. XAI, Sanjay already mentioned the Explainable AI program. All of these are resources available to the whole community. There's also the emergence of conferences and workshops. There's FATML, Fairness, Accountability, and Transparency in Machine Learning, AI for Social Good workshop at NeurIPS. There's a bunch more. I just put down the first two that came to my mind. There's an operational view I take of this problem, which is that I think of it, AI, and you can think of the AI stack in at least two different ways. One is the science view, and you can find the science view somewhere. There's also an operational view, which is you have sort of the physical assets, the compute and the storage at the bottom. Then you have algorithms, development environments, toolkits, and then the applications at the top. Taking them in order from the lowest level to the top, compute storage, these are, if you look at places like NSF, they make things like Exceed, these compute facilities available to the academic community, essentially for free. These are massive amounts of compute. But in a commercial setting, companies like Amazon and others are driving down the cost and are increasing the democratization of access to these compute facilities, so you don't need to be able to buy a massive GPU cluster in order to use it for an hour to do something. So there's that sort of change happening. The three layers on top of it, they're characterized by a lot of open source activity, but also product-based environments like Alexa and the Alexa Skills Kit that allow you to build apps on top of it within the kind of framework that Alexa operates, which is, you can talk to it, it's a voice-activated skill, things like that. It also, within those three, what funding is required for is to incorporate aspects of fairness, transparency, et cetera, into those resources. And then at the top, you have the apps. This is where most of the funding either goes or is needed. How do you actually develop the capabilities and solutions that are deployed out to accelerate social good applications? So what are we doing from an Alexa perspective? Or what are some examples? So one, I already mentioned, we launched this partnership where we're trying to work with the academic community in understanding what is the potential for fairness research and social good applications of the same. We also organized, there's a lot of social good skills. I think social good is one of those where you have to let 1,000 flowers bloom. You can just create the infrastructure, and then creativity will happen at the edge. This is not like a build and deploy broadly kind of thing. People will invent things. Problems are community specific, problems are geography specific, and we want to enable those communities, those geographies to innovate and address their problems as they are best equipped to do. So we organized a contest in 2018 to encourage creation of Alexa skills for social good. Out of it came sort of all these Red Cross skills for hurricane alerts, scheduling blood donations, et cetera. I won't read through all of them. You can look at them on the slides, and this will be posted later. One thing I'll highlight is language preservation. Just some time ago, we're talking with Native American populations, and there is this, regardless, independent of technology, there's these languages that are going away, and how can you use these broad-based resources to actually preserve language? And so that's something we're now investing internal resources and trying to understand what can we do to help communities use this to preserve local cultural artifacts of their own. Last, I'll up by saying, I borrow from Andrew Lowe, he's a professor at MIT. He said, we can do well by doing good. He said this in the context of AI and something else. And I often think we can say it both ways. We can do good by doing well. If AI does well and it goes out there, we can do good with AI. And so I did actually spend a little bit of time wondering. I said, let me stay true to the quote I'm borrowing. So that's why it's doing well by doing good. A couple of examples, both from this year. One, people with disability. Once you put resources out there, capabilities out there, and you take care to make them flexible, customizable, that allows people to unleash their creativity and then figure out how to adapt it to their unique situations and get benefit out of it in ways that we've not anticipated or designed for. So one is people with disabilities how they're using AI to improve their lives. One example that was reported on NPR Nova is this child who is sort of seriously challenged, very limited vision, can't move. His dad helped figure out how to use the synthetic voice he's generating to command Alexa to do some things. And you should go read the whole story. I won't recount it here. But it's one of those things that made so many rounds inside and made a lot of us feel validated in the investment we're making, that this is a transformation worth investing, long nights in, saying this is how we've touched somebody's life. And the other is from, I can't not give an India example. It's how Alexa brought internet-based learning to a remote village school in Maharashtra. And this is also a super interesting story to go look on Google and read about how this teacher invested his own resources in buying an Alexa, actually personalized it, gave it a form, and then arranged a daily education session where kids can come and talk with Alexa to both improve their English and to teach Alexa, using the Clio skill, answers to questions that she doesn't know about and interact with it. So these are just a couple of ways in which nobody would have thought of developing it to do it in that way, but just putting this capability out there, you can do good. Thank you.
I'm going to stand up too.
Yes. Perfect. There you go. Next one. Next one. Perfect.
Okay, great. So my name's Jim Carosa. As Sanjay mentioned, the hat I'm currently wearing is I lead the Directorate of Computer and Information Science and Engineering at the National Science Foundation. But I've worn a couple of other hats recently. I worked in the Office of Science and Technology Policy for 6 months last year when we were just getting AI activities underway through the White House, and worked on a project with the OECD, the Organization for Economic Cooperation and Development, on developing a set of AI principles. And I want to give you just a quick perspective from those three viewpoints, and this is about AI for good. And I think what you'll see is that that notion of good and many of the issues that Prem brought up are woven through all three of these viewpoints. So if you haven't seen this, I'd recommend this. I'm also a professor, as is Prem, so maybe I can assign homework. If you haven't seen it, you ought to take a look at the executive order that was signed in February of earlier this year on maintaining American leadership in artificial intelligence. And I'm not going to go through the list of really important actions that are called for under the executive order, but there is a statement of policy and principles up front how critical artificial intelligence is for the country. And then under objectives, it talks about, first, the importance of R&D and, again, this collaboration between industry, academia, and the federal government. In R&D, it talks about access to data, to federal data, to models, to the kinds of computation that are needed to push forward the frontiers of AI. It also talks about continuing to enable innovations in AI while protecting economic and national security, and while also protecting civil liberties and privacy as well. And so that executive order's come out, and for those of us in government, that's a very important document. Also on the government side, there are a number of bills that are being discussed in Congress right now regarding artificial intelligence. There was a roundtable with members of the House Space Science and Technology Committee. You see a little picture there. Usually when we have these roundtables, actually there are folks from NIH, NSF, DOE, and NIST at this. And usually 3 or 4 members showed up. We had 20 members of Congress show up and stay for almost the entire thing, just to show the level of interest there. At the National Science Foundation, just now at the end of last month, we held a workshop on envisioning national AI R&D institutes. This notion that agencies were there, industry folks that we've been working with, foundations and not-for-profits were there, and thinking about if we were going to do things center scale, what were the areas where we might find collaboration among those partners along with academia. So I mentioned the Organization for Economic Cooperation and Development. That's an organization of 36 countries sort of committed to democracy and market-based economies. And again, now I'll give you even more homework to read. If you haven't seen it, they're amazing principles, and to understand that 36 countries and a number of non-OECD countries have signed on for this as well is really quite an undertaking, I think. And you see there human-centered values, inclusive growth, transparency and explainability, themes that have been talked about already, robustness and taking into account security and safety, as well as accountability. So those are some of the principles for responsible stewardship in our country, as well as 35 others have signed on for that. And then there is also a section on national policies, and again, the importance of investing in AI R&D. That's music to my ears at the National Science Foundation, where we actually fund 83% of the basic research that's federally funded in computer science flows through the National Science Foundation. And so the investments in AI R&D are incredibly important to the research community here, talking about building human capacity and international collaboration as well. So I've given you 2 pieces of homework. The last piece of homework was something that was actually released just yesterday that you might find interesting, also coming from the OECD, a book called Artificial Intelligence and Society. And the reason that I put this up here is because when we talk about AI for good or an issue like fairness, saying something like AI systems should be fair is just, it's way too high level, right? And one of the nice things, and one of the observations in this particular activity, which grew out of the AI activity at OECD I was talking about earlier, was this notion that we should think about the AI lifecycle, think about the system design, the models, the algorithms, and the data that drive it in the beginning. It's going to be deployed. Before we deploy it, we'll do validation and verification. And when it's deployed, we're going to do monitoring and assessment. And when you ask a question like fairness, is an AI system fair, you can look at it through this lens of the AI system lifecycle and begin to ask much more detailed questions like, well, if is it an issue with the data? So Sanjay was talking about that earlier. When I deploy it, who's getting access to it? When I'm monitoring it, am I monitoring everybody? Is there algorithmic bias involved? And so that's the last piece of homework that I'll give you. And there'll be no exam and no blue book or anything like that. And we won't collect it, but it's for your own. Let me finish up just by saying a word about the National Science Foundation and the activities that we're undertaking in artificial intelligence. Across the foundation, we invest $450 million in AI research, sort of broadly writ. That's core AI research. It's in applications and systems. And again, that funding, you should know this as taxpayers, that funding that comes into the National Science Foundation goes out to power research in our universities that both the previous speakers have talked about. At the National Science Foundation, we play an important role, again, with our colleagues from NIH and NIST and DOE. There's a select committee on AI that's co-chaired by the head of DARPA and my boss, the head of the National Science Foundation. There are subcommittees on machine learning and AI that Patty and I, our next speaker, are both involved in. There's an AI R&D strategic plan released in 2016. The update is due almost any day now. I'd assign it as homework. I thought maybe that was going to be my 4th piece of homework, but it hasn't come out yet. and international activities that you've seen. And lastly, I just want to say about innovative programmatics, and Prem mentioned this. At the National Science Foundation, we fund basic research in AI, and AI for good, and the social aspect and the social sciences aspect, collaborations between computer science and social behavioral and economic scientists. And so you see there in the middle the program that Prem mentioned, the NSF program on fairness in AI in collaboration with Amazon. We did something on AI and ethics in collaboration with Partnership on AI. And over on the right-hand side, this has to do with access to resources and computing resources. This is something we've worked on a number of times before with Amazon and other cloud providers. And we have something out that looks like Exceed, but it's with public clouds actually behind it. So, okay. And with that, I'm just really happy to be here. Thank you for the invitation, and I'll pass things on to Patty.
Thank you for the opportunity. I'm not going to stand up because I'm afraid I won't get back on the chair. I'm the director.
Thank you for distracting people while I did that.
Good tag team here. I'm the director of the National Library of Medicine, and you may wonder what a library is doing talking about AI, but a library is essential in ensuring that data are available, findable, discoverable, and well labeled. In addition to that, we also fund research in basic methodologies. The National Institutes of Health has 27 institutes and centers, all of which have some aspect related to artificial intelligence. And fundamentally, though, we are a problem-inspired institute. $37 billion a year at the NIH is spent investing in trying to solve the health problems and understand basic biological discoveries. We are particularly concerned right now in these 5 areas: cardiovascular health, gene therapy, Alzheimer's disease, lifespan development, and a fascinating initiative called the Brain Initiative, which has revolutionized the way we understand the brain from a biochemical model to an electrophysiological model. And the tools of artificial intelligence are essential all the way across here. For example, consider an Alzheimer's disease. Effective planning of exactly which voxel to sample for changing of white matter hyperintensities across the life of an individual requires machine learning to do effective treatment planning, effective assessment planning. Within the cardiovascular health, the discovery of fundamental pathologies as well as predicting of clinical outcomes relies on the use of good machine learning algorithms. The National Institutes of Health is very committed to open science and open data, and on the screen above you here you see many of the initiatives that we've invested in large public access data repositories. Our model organism databases, such as the fly or the mouse or the zebrafish, provide a biologically highly human curated knowledge base for use. The All of Us program is creating a 1 million-person cohort that will have a very unique approach to allowing for essentially passport-based access to research data, so new models of analytics can be developed on actual human data across a 10-year span of an individual's life. The STRIDES initiative, which Andrea Norris spoke of this morning, is the NIH's investment in ensuring that data are made available and stored in a sustainable and accessible fashion, not requiring investigators to download and manipulate data in a local environment, but allowing for management of data and analytics at a cloud level environment. We've partnered well with Amazon in looking at strategies that will allow us to integrate data sets across multiple, if you will, cloud instances without necessarily moving the data sets. We're also quite interested in the management of information across time. The NIH has had a very long-standing commitment to data and resource sharing. Beginning back in 2003, the NIH data sharing policy was initiated. But over time, this graphic should be illustrating to you the various activities that NIH has participated in to ensure that data are available and made useful. And in a few minutes, I'll talk about some of the considerations and constraints that we place on this. At the National Library of Medicine, we're specifically launching a new strategic plan over this decade, which focuses on ensuring the National Library of Medicine is a platform for biomedical discovery and data-powered health, and ensuring that our data repositories, we are the largest repository of biomedical data in the world, are made available and in a way that is safe and secure, and that our algorithms and our analytics that are developed are both problem-inspired but sustainable, reusable, and tractable. We are committed to interacting with users in new ways, and this requires us not only to rely on vision and individuals reading, but also to look at different ways that information is transmitted through an environment, through environmental cues. We recognize, third, that the development of a workforce necessary to make sure that the value of data-driven discovery and AI methods is met with the proper training both of biomedical scientists who will use these analytics, as well as data scientists with strong biomedical understanding who can create new analytics. We remain committed also to making sure that the citizens have access to information and data. Some of our research programs right now focus on translating AI data-driven discovery into the hands of individuals in our personal health libraries. Another initiative that we've invested in recently is a strategy to do computational debiasing of data sets. So we are able to accurately characterize the extent of bias and make sure that bias does not get perpetuated through analytics. We envision the library of the future to be a sphere where digital research objects are interconnected, and the library's strong suit is both in structuring under each of these ovals, creating a library for code, libraries of models, and making them accessible, as well as the interconnections between them, so that interested individuals or interested machine algorithms can enter the research process in any point and be able to be connected to investigators, to pipelines, to pathways and protocols. The library is essential to making sure that the resources of our data repositories are made available and useful for new discoveries, for care planning, and for treatment evaluation. However, there are some critical issues that the NIH is concerned about, and I want to draw your attention to 4 of these as we think about the use of AI for biomedical discovery. First, we are absolutely committed to rigor and reproducibility of our research processes, and you may all be quite aware that the ability to reproduce and understand an algorithm is incredibly complex. We have the value that algorithmic-driven analysis may actually be reproducible, but not necessarily human understandable. Second, the NIH is deeply committed to the protection of participant privacy. And this goes well beyond putting a big lock on the data sets to ensuring that the data are made available in a manner that is consistent with the individual contributors' wishes for that data. We work to help individuals understand how to participate in research, what data reuse means, and how to contribute to the overall growth of science and understanding. Third, as a library, we're deeply committed to discoverability of data sets, recognizing the importance of not only catalogs and discovery tools, but also ensuring that metadata describes not only the provenance of a data set, but also its potential uses and the consequences of those uses. And finally, as a library, we are focused on data stewardship, on the preservation and the sustainability and sharing. We've recently partnered with the National Academies to develop econometric modeling tools so that the anticipated life cycle costs of data and its potential value and uses can be known at the inception and not simply along the process of the data life cycle. I look forward to conversation with you, reminding you that using artificial intelligence to improve the health of citizens is about the best good that we could possibly expect. Thank you.
Okay.
Yeah.
Great. So good afternoon, everybody. Thank you again for inviting me to form part of this panel. You know, the topic is really timely and important. We live today in an era of huge social and geopolitical challenges, but also of unprecedented opportunity to create a better world through transdisciplinary convergent use of advanced digital technologies. You know, today our planet sustains about 7.6 billion people, more human life than ever before. And the population has grown from about 1 billion to 7.6. And if you look at the chart, it's a real hockey stick, right? It's a real exponential where we're going to head towards 10 billion people by 2050. This puts tremendous stresses on our natural resources and on the planet as a whole. We need to adapt as a human race to accommodate increased urbanization, a growing middle class, an aging population, climate change, and rising demand for food, energy, and natural resources. All of these stresses are creating very unstable geopolitical environments today that we haven't seen, the likes of which we haven't seen since the end of the Cold War. We've lived in a very comfortable, relatively comfortable world for the last 30 years. That is no longer the case. But at the same time, we also live in a time when discovery, innovation, and technology are advancing at rates never before seen. This convergence of big data, large-scale commoditized computing, and artificial intelligence, machine learning, deep learning algorithms largely developed in the 1970s and 80s, is creating a revolutionary transformation for society as a whole. So I'm a technology optimist. I'm a professor at Purdue University, but also an expert on technology and national security. And I think that science and technology advances like the ones that we're seeing today really promise tremendous paths for solutions to the wicked problems that we face in the 21st century. At the same time, however, this newfound power of digital technologies presents us with very serious ethical, social, and legal considerations that require fresh thinking and a new framework within which to develop the rules of the future. We heard from Jing about the OECD principles. That is a fantastic development over the last year that the administration and people like Jim and Michael Grazia and others have been very engaged with. It's great to see that because we do need those rules of the future and those fundamental principles. And, at Purdue University, we are very focused on this question of the intersection of ethics, social implications, and technology and legal issues, because we think it is a conversation that needs to happen, that needs to be a lot deeper than it has been in the last few years, as we have seen the development of these technologies happen. Nowhere is this more apparent than in the future of war and security. The United States and its allies are today in what undoubtedly is one of the most difficult and consequential technology races of the post-Cold War era. There's no question about that. Anybody that thinks that is not the case is not following the news, is not reading what is going on out there. Great power competition, and other state and non-state actors alike are making great use of today's technology race to advantage their economic and national security, sometimes in ways that might be considered abhorrent by liberal democracies the world over. Witness, for example, the attack on the foundations of American democracy in 2016 by Russia, or simply what is going on today in Beijing with the utilization of face recognition technologies, artificial intelligence methods to control the population of that city. The problems we're facing aren't new, but the technology makes us look at them through a different light. We need a global conversation on these topics. About a month ago, we organized at Purdue, as part of our 150th anniversary, a conference on the ethical, the title of the conference was Ethics, Technology, and the Future of War and Security. It was a very interesting, fascinating conversation in which people talked about what would it be like to think about security and conflict in a world in which autonomous AI-driven systems are able to wage such conflict and such wars in the future. The general tone was one of recognition of the inevitability of the advancement, but tempered by the idea that these technologies must have the seeds of ethics and morality sown deep into the soil of development. Right? Speakers concur in the hope that these advanced technologies may be used for good to make future wars more humane and even preventable. Inherent in the vision is the knowledge that a truly global conversation and robust debate is essential on how to define these rules and boundaries of future wars. I'll give you an example, and this is why advance and progress in these AI algorithms over the next few years is so important. As I said before, we are harvesting the progress that was made by mathematicians in the 70s and 80s, but we have a long ways to go. It's okay to have AI algorithms that make predictions on things like what book to read or what movie to watch. The consequence of error is not particularly significant. But when you're thinking about using AI and autonomous systems to wage war or prevent conflict, the consequence of error is really, truly existential. And so we need to make progress in this. I'll give you an example, and I'll close very, very quickly. I'll give you an example from a book called Army of None. It was written by a fellow called Paul Shary. He is at the Center for New American Security here in Washington, D.C., and it describes the current progress and the world in which AI, robotics, and autonomous systems might be waging a war. He gives an example at the beginning of the book. from the time when he was with the Army Rangers in Afghanistan. He was a soldier with the Rangers. He was a ranger. And he and his team had to go up a mountain, a hill in Afghanistan to observe a road that was leading into a village because they suspected there was terrorist activity going on along that sector. They went up to the top of the hill. In the morning, they saw a 10-year-old girl walking from the village towards their position and kind of circling around. And as they watched this 10-year-old girl, they realized that she wasn't just, with her sheep walking happily along the pathways there. She actually had a radio and was radioing back their position to the village. Now, they had a decision to make. Under the rules of war, it was perfectly legal for them to shoot the girl and kill her. And Paul Shary asked the question in the book, if an artificially intelligent robot had been up on top of the hill, what would have happened? They made the decision not to shoot the girl, to go down the hill and come back another day, even though they were perfectly within the legal bounds to do so. A robot driven by an artificial intelligence that is based on the rules of war could have shot the girl. So those are the consequential things that we're facing today that we need to think about and that we need to have a dialogue about and keep making progress in transparent, explainable, fair algorithms for artificial intelligence. The consequences are really tremendous. So let me close with that, and hopefully we'll be able to have a dialogue going forward. Thanks.
All right.
So thank you all for being here. So I want to bring you down to earth. I'm going to give you my experience being on the ground doing work in this space. And the Hariri Institute at Boston University is at that intersection between computer science and all the things that result in social good. And let me just start. Well, the title will be obvious why I'm saying what I'm saying, sharing knowledge without sharing data in a second. But let me just start by saying we are all very used to this model of how machine learning works. You start with some training data. From that, you get a model. You're going to use that model along with new input data to make some predictions or action. So this is the workflow. Now, let's take a closer look at this picture. This top row right there, how are you going to get the training data? The training data has privacy. We heard from the library perspective, privacy of the individual records, of the companies, et cetera. So there's a privacy question. And that actually, machine learning alone shown that it's very vulnerable to this. I don't know if you've been following the news. It turns out that if I use machine learning to build a model, somebody can use the model to figure out the data of the individuals that were used to develop the model. So what kind of ethics is that? I'm going to use somebody's data to build a model, and then later on, that data can be revealed. For example, I can tell if somebody has cancer or not by querying a model where their data was used to build that model, right? So adversaries can pollute the input to come up with actions that were not intended. So that's another unethical use of it. I'm here to tell you that newspapers are always interested in the sort of catchy stories, right? So they're going to tell you all the problems. AI is bad because look at what can happen. What they're not telling you is we computer scientists have very good solutions for these things. The fact that they're not being used is not our mistake. People should use best practices. So here is one. It goes back 10 years ago. A group of faculty, including one currently at Boston University, Adam Smith, developed an idea of differential privacy. What is differential privacy? Differential privacy says if you're going to use data to provide answer, then this is how we define privacy. Is there a way to tell if that individual, the bottom one, is in the data set or not by somebody outside? So if you are the adversary out here, and I give you two data sets, one where that person is in the data set and another one where they are not. If I can prove to you that there is no way for an outsider to tell whether that person is in the data set or not, then I protected the privacy of that person, right? So just think about that for a little bit. We have a definition. We actually have a promise. Can it work? Yes, it can work. How do we do that? So now imagine I take the data from the library, and instead of giving access to all the data, because that's a problem, here's what I'll do. I will actually produce multiple versions of the data, different cuts. Think about it as different samples. And now I give this data to different machine learning algorithms. Every one of them will develop a model. Now, one model had my data, the other one doesn't. Correct? So now I have 4 different models generated. Now I can use differential privacy to cloak these models. I get them, I can query them all, do some sort of voting across them, and now the one result that comes out, provably because of differential privacy, will be protected. And indeed, there is a platform out there that allows you to do that. So this is a way to show that I can apply best practices developed in computer science to protect individual privacy. Now, what about the rest of the machine learning pipeline? Well, here's the other bottom part. What is it? It's another function, right? What I do is I use some input data now, which is also private, by the way, and I use the model that was used to train the machine learning, give these to some algorithm that is going to produce some prediction or some action to be taken. Okay, there's a problem because I want to make sure that this function right here, this predictor, does not leak anything about the private data coming into it, or actually the model itself, which is a trade secret in some cases. Turns out there is a solution for that too. It's called multi-party computation from computer science, which says you can compute any function on data while this data remains private. In other words, I can derive a function out of input that is locked and not available for me to take a look at through things like cryptography and so on. Now, I'm going to tell you that we use that. Here's a particular example in the city of Boston. Back in 2013, I'm thinking about social good and public good. The late mayor of the city of Boston got a bunch of companies, big companies, okay, to sign a pledge that they will help him figure out the gender pay inequity between men and women doing the same work. So the companies agreed, we'll help you, mayor, to do this. If you read one of the goals of that little piece of paper they wrote, the companies or the employers agreed to contribute data to a report that will be compiled by a third party to allow the data, the payroll information. This is not volunteer data. It's not just a sample. It's every record. Now, the issue were the lawyers. The lawyers said, on our dead body, this data is not leaving our company. Of course, you can see why. Even the IT folks said, well, this data is so secure, we cannot trust anybody with it. We're never going to send it to anybody outside. So here you have a situation where the data cannot be shared, period. Even if it's not going to happen. Can you still compute that function? The answer is yes. Multi-party computation did it. As a matter of fact, 2 reports in a row worked on the third one. They're out. You can read it. It's the only study in the whole world that is based on real HR data that would tell you correlations with length of employment, race, gender, you name it, right? So the fun part about this, honestly, well, by the way, this made it also in DC, and now there is bills passed in Congress that make reference to this study as an example of a best practice when it comes to protecting privacy and so on. But let me say that the best thing that I can refer to about this study is who speaks for multi-party computation. I'm a computer scientist. I do that work, so I'll speak for it. But what if the mayor of your city speaks about it? To me, that's the ultimate sort of evidence that when you teach and when you tell people how to do things the right way, they become your advocate. What if the co-chair of the Boston's Women Workforce Council, none of these have anything to do with STEM education, yet they appreciate how computer science was able to do that. And by the way, how do we do that? It's a lot of talk to people. You have to explain to them how this works and why they should trust it. So this is very important. So with that, I just want to go to, oops, there was one more slide, which is, okay. Well, let me, okay, go ahead.
So I got several questions. Thank you so much for sending it. So since you're the speaker, so how can we, one of the questions is, how can we balance the need for the efficiency and an exploration with fairness and sensitivity of users? That's Grazia.
Okay, so I had actually two messages I wanted to finish with. The first one was, is we have to really educate about the availability of these best practices. And also we have to fix the narrative. So insisting that you have to share data may not be the right narrative. It could be you have to secure the privacy of the data. That's really what you want to do. So that's the first one. The second one is we have to have empathy. When we deploy these solutions, what we realize is the city of Boston is totally under equipped to deal with technology. So it is a great thing to show them some beautiful results that will be social good, but unless you help them deploy it, it is not going to work. So really we have to put ourselves in their shoes and develop solutions where it doesn't require them to redeploy everything. That's very expensive. They cannot do it. It has to be integrated into their workflows. They trust you when you do that because they know you're not selling them something new. You're really trying to fix their issues.
No, thanks. Also, I mean, community involvement is extremely important. One example I can give, Jim knows it. So Jim funded, NSF funded a project called Array of Things. So what that means? It means is, you know, in a lamppost or in a post there is an object which has a camera, and it was deployed in Chicago with a camera, with a voice and other things so that you can monitor traffic and you can take some actions or you can do some pattern recognition, right? In the beginning, it was really not accepted. You know, it's violates privacy. But this was done by Argonne National Lab, an all academic institution. No company was involved. But what they did, you know, they stepped back and started talking to the community leaders. They explained what is happening. They showed what the securities are and what are the layers of securities are. Today, state of Illinois is involved. Multiple states are involved deploying it. In fact, international countries are involved. Netherlands is part of that. So social involvement is extremely important. And unless you explain it, and get community involved, it's really hard to do that. Yes, Jim, please.
So I'd like to take a crack at answering that question. Sometimes you can't get what you want. So it's wonderful when you can get what you want because you apply really beautiful computer science to it, like the multi-party computation work that Azhar was talking about. In other cases, it becomes a much more complicated social process about how you decide where to trade things off. So for example, one can trade off accuracy of prediction versus the robustness of the algorithm. So you don't have cataclysmic failures when the input sets are just slightly perturbed. And that's a trade-off that you know, maybe slightly worse average performance, but much better performance with respect to variation. And that's just a trade-off that AI system developers and deployers and actually when it comes to society in general that we have to be able to make informed choices.
One more question, and it's up for grab. How do we protect open ethical AI from being defeated by unethical misuse by businesses and other countries? Anyone take? So this came from Joe.
I'd be happy to take a crack at that. I think the first thing to ask is, to what extent do we have policies and laws in place already to protect ourselves? So for example, if you think about using AI for prediction, well, you know, we've been doing regression analyses for a long time, and certain, you know, industries like insurance are very highly regulated, and they have to demonstrate certain fairness properties in their decision making. And just because it's an AI system as opposed to a simple, you know, linear regression or some kind of simple statistical model that's been around for a decade or multiple centuries, the decision is still the same thing. And I think the question that we should always ask ourselves first is to what extent we have existing procedures, policies, and legal frameworks in place to protect us against those very real concerns.
Absolutely correct. I completely agree that we have to have explanatory, but also involvement from the community side as well, and use best practices, including the ones you mentioned. So I think, I mean, in order to do this, I honestly think everyone needs to be involved. It's a very complex process. Social scientists we need, data science we need, engineering scientists, and technology providers. Like my example I showed, Google or Amazon or AWS will not, they will be part of building the road for you. But there has to be a traffic light in this AI-based infrastructure. And it's a reality, right? We all are using many of the AI-driven services and usage, right? So it's really, the conversation is just starting, and we all need to play a part of it. So that's what I said, let's get started. Jim and many other, from Amazon side, we started working with NSF. This is, the deadline to apply is 25 June. This is roughly about $7 million project. NSF is going to select 6 to 9 people. We invested quite a lot into that. If you look at it, who are the directorates involved? Just for the sake, Director of Computer Science and Engineering, but there is a Director of Social Behavior Sciences there too. And do you know the selection process is such that we contributed to the funds, but none of us will be involved in any sort of decision. So it will be selected by NSF, and the study will be done by awardees. And
let me just correct one
Yep, sorry,
thing there. It's actually a $21 million award over 3 years. This is the first call for proposals. There'll be 2 more.
Okay.
So it's, I just want to make sure.
No, it's sorry. Okay. Yeah, so it's a substantial funding, let's put it this way. So please get involved, please apply. And here, as I said, the terms and conditions are NSF will award it, we stay out of it, and people do studies, and let them publish it. And that's the best way we thought, one of the first steps we can take towards fairness, transparency, accountability, and ethics. With that, thank you so much for coming, and wish you a wonderful evening.